We're now going to talk about some topics related to managing the life cycle of Java threads. And this, of course, is going to be informational because it's important to know how threads work in general, especially to know the expense that they incur so you don't use them wantonly. Even if you end up using things like thread pools, it's still going to be helpful to understand how the Java thread lifecycle behaves, because if nothing else, there may be situations where you have to cancel threads, and so it's important to know how to interrupt them and get them to shut down. So we're going to start out by talking about the concept of the life cycle of a Java thread. And the primary focus in this lesson, this overall lesson on managing Java thread lifecycle states, will be on starting and stopping Java threads. Those are the most important things you have to be aware of. So whether you realize it or not, and you might not realize it if you just are an application programmer of Java, a Java thread internally is a very complicated entity, has a lot of different moving parts. In particular, a Java thread interacts with many other entities. It interacts with Java and Android runtime threads. It interacts with the libc API, or the equivalent in Windows. It interacts with kernel level threads. It interacts with hardware cores. So there's a lot of stuff going on under the hood. And even though the programming model is very simple, the mechanisms that are happening behind the scenes are complicated. Therefore, it's important to understand how a thread lifecycle is managed. As we'll see, some of these things you control, some of these things you control either directly or indirectly. Other things are happening behind the scenes. And so what happens is a thread will transition through various states based on operations that occur while the program is running. And as I said before, two of the key states we care about are starting and stopping Java threads. So we'll pay particular attention to them. Now, again, it hopefully goes without saying, but I'll say it anyway for completeness. You don't have to understand all of these details in order to program threads effectively. However, the more you know about the full stack and understand these things, the more valuable you'll be if you go off and get a job in the computing industry. There's something called the coveted full stack developer who's able to write code at multiple levels, or perhaps all the levels of abstraction. Now, again, very few people need to do all these things, but it does make you more beneficial. It raises your value proposition because you can attack problems more systematically and deal with things that occur at multiple levels of abstraction. In particular, knowing more about how systems work can help you to avoid commoditization. That's the dreaded outcome where too many people know what you know, and therefore your value proposition as a software developer goes down because you become an interchangeable part that can be swapped out for somebody who perhaps is willing to work for less than you do, or maybe has less experience, but is able to do more or less the same thing you do because your skill set is commoditized. So you always want to avoid being commoditized if you can. Okay, so that's just a quick overview of Java thread lifecycles. We will now turn our attention to the different aspects of that, starting, as we'll see in a moment, by covering the different states that a Java thread can be in during its lifecycle.